So, hello everyone. Welcome to day 43 of learning data science. Basically, not day 43, it's actually day 44. So, pardon me with that. So, what we are going to do today, we are going to discuss about the some of the plots, graphical representation, some of the things, and also we will discuss about the skewness and kurtosis. Basically, what do you mean by skewness? What do you mean by kurtosis? Okay. So, let's not waste much of the time and start with the things. Okay. So, hang on. Yep. Okay. So basically, we have discussed about quite few things, which what is mean by variance, what is standard deviation, what is range, first moment, second moment, business decision, all these things we have discussed. Now we will start with the third moment business decision. And basically, what's the third moment business decision? Third moment business decision is usually called as skewness. Okay, is usually called as skewness. And what do again mean by skewness? Skewness is again um, a measure of symmetry of the data, matlab, a measure of symmetries of dispersion. Okay, for example, I will write here what is a skewness. A skewness, it is a measure, it is the measure of symmetry in distribution. Again, what do you mean by symmetry? Okay, so what do you mean by symmetry is, for example, this is a histogram. Okay, this is a histogram. This is a, for example, this is a histogram. This is my data points. So basically, this is a histogram. And what we do when we draw a line like this, uh, so when we are drawing any line, and for example, if we are cutting this line in a equal two halves, okay, so you can see here somewhere at the right, somewhere here, my data is skewed. Okay, you can see here somewhere here my data is skewed. It is not symmetrical in shape. somewhere or the other, my data is skewed. It is not symmetrical in shape. So for that particular reason, what happens? It determines that my data contains some outliers. And how it is outliers? You can see this is at the right hand side. Okay. So if my data is skewed at right hand side, then we can say that my data, my skewness is right skewed. And whenever my skewness is right skewed, so you can say it is greater than zero for right skewed. For right skewed, always my skewness will be greater than zero. Okay. And how we will again check the skewness? You will check the skewness whether it's my normally distributed or not. Okay. So for example, if you want to check it that what is right skewed, how it is normally distributed and all. So for example, I'm taking a normal graph, and here I'm drawing line like this. Okay. And if I will cut it into two halves, so you can see these two halves, this first half and the second half, it is symmetrical in nature. What it is? It is symmetrical. It is it is symmetrical in nature. And what type of distribution it is? It is normal distribution. It is normal distribution. I hope you guys are with your pen and paper and noting down these things, because I don't want you guys to just sit it on your sofa or in your bed, because it might be a boring stuff for you and you will sleep. So for that reason, I want you to just take your copy, pen and paper, and just note down these things, whatever things I am explaining here. Okay. So this is normal distribution. When it is normal distribution, when we cut the graph in a symmetrical way, when our graph is being divided into two halves in a symmetrical way, both the sides is identical, then it is called normal distribution. Okay. And now I will take, if my graph is somewhere like this. Okay. If my graph is somewhere like this, and if I cut it into two halves, then you can see on my very first thing. Okay. On my very first, the graph is not identical. It is left skewed. Okay. My graph tends to bend towards left. Okay. So what we can call it? We can call it as left skewed. Why it is left skewed? Because it is not symmetrical in nature, and on the left side, my graph, which is on the left side, my left portion is tends to bend more. For that particular reason, it is left skewed. And again, how it will be identified? It will be identified by looking at the graph. Okay. It is left skewed. And when it is left skewed, my skewness value will be less than zero. Okay. my skewness value will be less than 0. And when it is right skewed, for example, if my graph is like this, if my graph is like this, okay, and if I will just divide into two equal halves, then you can see my right side, my second portion is not symmetrical, okay, because this particular thing is my outliers. This particular things is my outliers, okay. And when it and when it is right skewed, then the skewness value, what will be the skewness value? Skewness value will be greater than 0. Skewness value will be greater than 0. Now let's move on to our spider. Okay, and here in spider, what I will do, first we will take a histogram. And basically what's the histogram means? Histogram, it represents the frequency distribution. It represents the frequency distribution. And again, what's the primary purpose for my this particular graph? What is the primary purpose? The primary purpose is to identify the shape of distribution. The similar way which I have showed now on my whiteboard, that what is the how we can determine the shape of the distribution by seeing it. Okay, so my primary purpose is to see the shape of the distribution. And what is my secondary purpose? Secondary purpose is to identify the outliers or extreme values. Okay, so just keep it in mind. Okay, this is again a interview question for you, so make sure to note this. What is the primary and secondary purpose of histogram? So primary purpose is to identify the shape of the distribution, secondary purpose is to identify the outliers. And how we can identify the outliers, I have shown now. Okay, and now one more thing to keep it in mind. Okay, and whenever we are talking about skewness, and whenever you are talking about left skewed, then in my left skewed, my skewness value will be always less than 0. Okay, and when I am talking about right skewed, here my skewness value will be always greater than 0. And when it is normally distributed, when it is normal distribution, my skewness value will be equal to 0. Okay, and again one more thing to keep it in mind. Whenever it is left skewed, whenever it is left skewed, uh, negatively skewed, so my mean will be always less. Mean will be always less than median. Then comes the mode. Okay, and whenever it is right skewed, my mean will be greater. Mean will be greater than median. Will be greater than mode. Okay, and whenever it is normally distributed, then my mean, median, and mode will be equal. So by these things, you can identify the skewness, that how it is skewed, how the graph is skewed, whether it's normally distributed, whether it's right skewed, whether it's left skewed. If the skewness value is less than 0, then we can determine, okay. And also you can check with the first moment business decision, you can calculate mean, median, mode. If the mean is greater, if the mean is highest among all, then you can say that it is right skewed. If the mean is lowest among all, then you can say it's left skewed. If mean is equal to median is equal to mode, then you can say that it is normally distributed. Okay. So these all things were there for, we discussed about histogram, we discussed about skewness. Okay. And tomorrow we will discuss about the kurtosis. What do you mean by kurtosis? Okay. So just note these things. This is a important interview question, that what is the primary and secondary purpose of the graphs. Whatever graphs we will be learning, you will be asked the primary and secondary purpose. And again, one more thing which you have to keep it in mind, that what is the formula for skewness. Okay. What is the mathematical formula for skewness? So the formula for skewness is summation of sum of, here you can write x I xi minus mu. Mu is here again my mean, whole to the power uh, divided by standard. First I will divide it, divided by standard deviation, whole to the power 3. Okay. So this is my formula for skewness. And again, how we can determine it, means like I will show you by writing it. The formula for skewness is, what we can do, we can write here summation of x I xi minus mu divided by standard deviation. Okay. Whole to the power 3. Okay. Here xi is my data points, is my data points. This is my standard deviation. This is my standard deviation, and this is my mean. This is my mean. Okay. So I hope you have understood it. What's the formula for standard deviation? Okay. So you guys just keep practicing it. I've explained about today what we have discussed. We have discussed about the formula for standard deviation. We have discussed the distribution, no, positive skewed, negative skewed, normally distributed. We discussed about histogram, the primary and secondary purpose. We discussed about how it is skewed when it is positively, negatively, and normally distributed. So these all things we have discussed today. And tomorrow we will start with the kurtosis. Okay. So till then, keep practicing it, and see you tomorrow. Goodbye. Take care. Jai Hind.